So we're going to continue checking for symmetry and anti-symmetry. Okay, so we're looking at this set of relations again that we've visited before. So these are pairs of points where this condition is true, and it's on the set of all the integers, so positive or negative integers. Right, so we need to figure out whether they're symmetric or anti-symmetric. Okay, so let me kind of do symmetric is here. Let's do anti-symmetric here. Make a little table of values. Not table of values, but we'll put each relation in each category. Okay, so symmetric and anti-symmetric. So relation could be one, could be the other, it could be both, or it could be neither. Okay. So let's see. Let's look at R1. Okay, so R1 is the pair of points for which A is less than or equal to B. So we have these pair of points where the first number is less than or equal to the second number. Okay, so is it symmetric? Okay, so the answer for that would be no. Okay, so it's not symmetric. Okay, and the reason for that is that if I have something like this, 2, 3, right, where 2 is less than 3, then 3, 2 cannot be in the relation because 3 is not less than 2. Okay, so it's not symmetric. Okay, so let's see if it's anti-symmetric. All right, so if I have AB, it's is in the relation, is in R1. Okay, then its opposite cannot be in R1. Okay, so but remember that anti-symmetry, you need to look at A and B are different from each other. So you don't really care whether the doubles are in. Okay, so it's like the doubles are in R1 because 2 is less than or equal to 2, 3 is less than or equal to 3, and so on. Okay, so this is gonna be anti-symmetric definitely, because if something like 2, 3 is in there, right, then 3, 2, its opposite will definitely not be in there, because if 2 is less than 3, 3 cannot be less than 2. Okay, so because A is less than or equal to B, then B cannot be less than or equal to A, then that kind of holds with the anti-symmetry. Okay, so R1 is an anti-symmetric and it's not symmetric. All right, so let's look at R2 now. So R2, we have the pair of points AB where A is bigger than B. Okay, so this is not symmetric. Okay, again, we can give a counter example, right? I have 3, 2 fulfills this rule, but 2, 3 is not going to fulfill it, so it can't be symmetric. All right. It's going to be anti-symmetric because for all the values like A and B are not equal to each other, if AB is in R2, right, if the first number is bigger than the second number, then the reverse is not going to be in R2 because B is not going to be bigger than A. So R2 is also anti-symmetric, but not symmetric. Okay, let's look at R3. Okay, so R3, we have the pairs of points where either A equals B or A is not equal to B. Okay, so what's going to be in there is pairs of points where they look like this. So we have both numbers are the same or the numbers are opposite of each other. Okay, so this relation is both symmetric and anti-symmetric. Okay, because it doesn't break the rules. It doesn't break the rule of symmetry. It doesn't break the rule of anti-symmetry. Okay, So you can see that, right, it's sort of really to kind of check if things are symmetric, you need to look at values that are different from each other when A is not equal to B. Right, so you can see that this is symmetric because if A isn't there, then it's, when you switch them, it's the same point. All right, and if not A isn't there, then automatically negative A and A also has to be in there. And, ooh, okay, never mind. Those negatives are tricked me there. Okay, so it's symmetric, right? It's going to be symmetric, but not anti-symmetric. So these will break the anti-symmetry rule. Okay, so let's kind of think about this, right? So if 2, -2 is in there, -2 and 2 is also going to be in there because you have all the points of this form, but this breaks the anti-symmetry rule because 2 is not the same as -2, and both points are in there. It's not going to be anti-symmetric. So this one is symmetric only. Okay. All right. R4 is both symmetric and anti-symmetric. So R4 is all the points where A is equal to B. All right, so it's only the doubles that appear in there. All right, so you're going to have things like 1, 1, 2, 2, -2, -2, and so on. All right, so this is going to be both symmetric and anti-symmetric because it doesn't break the anti-symmetry rule. All right, let's look at the next one. Let's look at R5. Okay, so R5 is coordinate points where the first number is one more than the second number. Okay, so they look like this. Okay, so let's see, you're going to have points like 3, 2, and 4, 3, and 5, 4. Okay, so notice that this cannot be symmetric because if I have 3, 2 in there, 2, 3 cannot be in there, right? But it's going to be anti-symmetric. Let's see. My table is getting a bit disorganized. So we checked R3 was symmetric only. R4 was both symmetric and anti-symmetric. That should have been R4. R5 cannot be symmetric, but it's definitely anti-symmetric. All right, and let's look at R6. Okay, so R6. A plus B is less than or equal to 3. All right, so we're going to have pairs of points like this. Okay, so let's check for symmetry, right? So A plus B is less than or equal to 3. So there might be values like close to 3 that will break the symmetry rule. So let's see if I have. No, that won't break. Okay, so because anything that's add up to be less than 3, right? So if I have numbers A, B, so A plus 3 is going to be less than or equal to 3, then B plus A also has to be less than or equal to 3. Okay, so that will be symmetric. That will work for symmetry. Okay. But for anti-symmetry, so anti-symmetry rule is broken, right? Because something like 1, 2 works. It's less than or equal to 3, but 2, 1 is also going to work. So R6 is not anti-symmetric. All right. So I guess sort of sometimes you can see these right away. Sometimes it kind of takes time to reason through it. All right, so it took me 10 minutes to this is example. Just sort of just kind of slow down and think about what's going on, especially if you can't see all the coordinate points in the relation. If they're given by a rule, you have to kind of think through and reason to see if they are symmetric or anti-symmetric. All right, so let's look at this relation again, the divides. Okay, so this relation is all the coordinate points where A divides B, and we're trying to figure out if it's symmetric or anti-symmetric. All right, so I'm going to say it's not symmetric. Okay, because it will have something like this. 2, 4 is in R, because 2 divides 4, but 4, 2 is not going to be in R, because 4 does not divide 2. Okay? And it is anti-symmetric, okay, because for all the values where A is not equal to B, if A divides into B, then B is not going to divide in A. Okay, cool. Okay, so let's look at a transitive relation. So this is another property that we're going to define. So a transitive relation is a little bit like a chain rule kind of relation. So it says if R is transitive, if and only if, whenever A are B and B are C, then A are C. Okay, so that means that if A and B and B and C are in my relation, then AC has to be in the relation. So if A is in B and if A, B, and BC are in R, then AC has to be in R. Okay. Again, just like with the others, if this is false, okay, then the relation is transitive by default. Okay. So, so it's only, you're basically checking to see if the rule is broken, right? If the pieces are not even there, then it's going to be transitive by default because of that if-then relation. The conditional is automatically true if the premise is false. Okay, so let's look at our relations here. So for R1, okay, so I see that 1, 2, and 2, 1. So basically you're looking to see like for pairs of numbers like this where they connect, like the end of one is the starting of the other. So 1, 2, and 2, 1 are in here. That means 1, 1 has to be in there. Okay, so 1, 2, and 2, 1 are both in R. And I also see that 1, 1 is in R, so that's good. Okay. Now let's see, 1, 2, and 2, 2 are both there. Then that means 1, 2 has to be in there. So yep, that works. All right, let's see any others. So basically anything else that starts in 2, no. Okay, let's see if anything like 1, 1, and 1, 2. So 1, 1, and 1, 2 are both in there, and 1, 2 has to be in there. Okay. Notice also that you don't really have to check things with doubles in them. All right, so I'm kind of check things with doubles, but if you do the transitive relation with the doubles, then you end up with like one of the points. It's kind of like an identity sort of thing. So you don't really have to check things with doubles because they're automatically true. Okay, so it's kind of a waste of time. All right, so let's see. Okay, so again, doubles we don't need to worry about checking with. So you basically could just like cancel them from the beginning because it's when you pair them up with something, they're always going to sort of give you the other point. Okay. Okay, so let's see, 3, 4, and 4, 1. Okay, so let's put these together. So 3, 4, and 4, 1. Because those aren't there, 3, 1 has to be in there for it to be transitive, and 3, 1 is not there. So this means this is not transitive. Okay, so you're kind of looking for breaking the rule. Okay, so basically you're sort of looking for points where the second of one point and the first of the other, you can connect together. And this sort of, if you form a point from the A and the C, if that's not in there, then it's not transitive. But if you can't find points like this to start with, then it's transitive by default. Okay, so let's look at R2. So kind of sort of ignore the double. You don't have to sort of make any pairings with those. 1, 2, and 2, 1 are in there. That means that 1, 1 has to be in there, which it is. So this is transitive. Okay, let's look at R3. So again, sort of you don't have to worry about pairing anything up with the doubles. So let's see, 1, 2, and 2, 1. Okay, and 1, 1 is in the set, so that's good. All right, so anything else that ends in a 2? No. Let's see, 1, 4, and 4, 1. Okay. And 4, 4 is in there. Okay. So it looks like I sort of done all the pairings possible, and this is transitive. Okay, so R1 was a no, this is a yes, this is a yes. Okay, let's look at R4. All right, no doubles. Okay, so 2, 1, nothing else ends in 1. Okay, so basically we can ignore this. Maybe. Actually, we don't ignore it. 3, 1, nothing ends in 1. So let's see, 3, 2, what could I pair this up with? 3, 2, I could pair up with 2, 1. Okay, and I need to see if 3, 1 is in there. Okay, so 3, 1 is in there, that's good. Okay, 3, 2, so 4, 1 I could pair up with nothing. 4, 2 I could pair up with 2, 1. And 4, 1 needs to be in there. And is it? 4, 1 is in there. Okay, and 4, 3 I could pair with 3, 1 and 3, 2. Okay, so 4, 3 I could pair with 3, 1. And 4, 3 I could pair up with 3, 2. So 4, 1 should be in there, which it is. And 4, 2 should be in there, which it is. Okay? All right. 4, 3 pair up with 3, 1. Yeah, I did that. Okay, so yeah, it's sort of just looking for all the possible pairings is hard with the transitive. So R4 is also transitive. Okay, let's look at R5. Okay, so I don't need to pair up the doubles with anything. They could be a result of a pairing. That's good, but you don't need to sort of double, like 1, 1 and 1, 2 is going to give you 1, 2. So it gives you the original one. So let's see, 1, 2, and 2, 3 would go together, and 1, 3 has to be in there, which it is. Okay, 1, 2, and 2, 4, and 1, 4 has to be in there, which it is. Okay, and I can't pair 1, 2 with anything else. How about 1, 3? 1, 3, and 3, 4. So 1, 4 has to be in there, which it is. Okay. 1, 3, and nothing else begins in 3. How about like 1, 4? What begins in 4? 4, 4, which it's okay because it's a double, so I don't need to look at that. All right, 2, 3. What starts with 3? 3, 4 starts with 3. Okay, so 2, 4 needs to be in there, which it is. Okay, let's see, 2, 4. Nothing starts with 4 that's not a double. 3, 4, nothing starts with 4, that's a double. So everything checked out, so that's also transitive. Okay, now R6. R6 only has a 3, 4 in it. Now that's transitive by default because we don't have anything in there in the relation that looks like that. You don't have things to pair up. So if this premise is false, then the property is true by default. So this is true by default. It's like by vacuous proof, basically. Okay. So the only one that wasn't transitive, it was R1. Okay, let's end the video here.